Glen ABG monograph. Bismillah ar-Rahman ar-Rahim. Here I'm collecting all these different monitors: strong ion difference, buffer base, strong ion gap, anion gap, and base excess or deficit. When you look at the extracellular compartment, it is characterized by electron neutrality. The positive charge, these are the cations, sodium, potassium, calcium, magnesium, equals the negative charge, the anion, chloride, bicarbonate. These are the fixed acid, lactate, keto acids, total weak acids, and all these anions equals cations. These are the different monitors we use. When we come to the strong ion difference, sodium forms the largest cation in the extracellular compartment. Chloride forms the largest anion. When we say sodium minus chloride, this means this equals the bicarbonate plus the fixed acids plus the total weak acids. These total weak acids, as we see here, it is albumin, globulin, and phosphate. These weak acids are anions, and their charges equals 16 milliequivalent per liter. So when I say strong ion difference, sodium minus chloride, this will equal this total weak acid 16 plus bicarbonate 24 equals 40. When it is 40, this is a neutral. More than 40, this is an alkalosis. This means that this will be large, or this will be large, to be positive. When it is less than 40, it is an acidosis. This may be less, or this may be more. When you come to the buffer base, this is a bicarbonate plus the total weak acids. Bicarbonate 24, total weak acid 16 equals 40. This is a normal. More than 40, this is alkalosis. Less than 40, this is an acidosis. Strong ion difference, so the difference between strong ion difference and buffer base will give us the strong ion gap. This gap, so this is the difference, this is strong ion difference, minus this buffer base equals that. And this is a fixed acid, keto acids and lactic acids. Usually it is close to very small, usually it is 0. When we come to the anion gap, this is the difference between sodium, this is a cation, minus anion, chloride plus bicarbonate, this will equals the total weak acid, which is 16. But here, we didn't add potassium. If it was potassium, it will be 16. Without potassium, it is 12. The base excess or base deficit, if the bicarbonate is normal, this is 0. It is more than normal, this is the base excess. Less than normal, it is base deficit. What will happen with diarrhea? Diarrhea, there is a loss of bicarbonate, but at the same time, there is a gain of the same milliequivalent of chloride. If we lost bicarbonate 10 milliequivalent, we'll gain 10 milliequivalent of chloride in order to keep the electron neutrality. It's very important. So in diarrhea, there is loss of chloride, loss of bicarbonate, and gain of chloride. Gain of chloride, this will increase. So the difference between sodium and chloride, which increased, will be less than 40. This is a hyperchloremic. This is an acidosis. When we come to the bicarbonate, there is a loss of bicarbonate. So this is a bicarbonate decreased. So the buffer base will be less than 40. This is an acidosis. Did we add any of these fixed acids? There is no lactic acid. There is no lactic acid or keto acids. So the strong ion gap which is the difference between this and that, will be 0. When we come to the anion gap, we have mentioned that there is loss of bicarbonate with gain of chloride with the same mole equivalent. So this is a loss of 10, gain of 10. So the anion gap will be the same. So no normal anion gap, no change in the anion gap. It will be normal. Here there is loss of bicarbonate. So this is a base excess or deficit. It is a base deficit. So in diarrhea, you will find this is a hyperchloremic metabolic acidosis with normal anion gap and base deficit. Vomiting, this is on the contrary. Vomiting, there is loss of chloride with gain of bicarbonate with the same mole equivalent. When you come to this strong ion difference, there is loss of chloride. This is hypochloremic, more than 40, metabolic alkalosis. What will happen? Loss of chloride, gain of bicarbonate, increase in the bicarbonate, this increase in the buffer base. Increase in bicarbonate, increase in the buffer base, so it is more than 40, metabolic alkalosis. When you come to the base excess or base deficit, is increase of bicarbonate, it is a base excess. What about is the strong ion gap, the difference between this and that? There is no fixed acid has been added, so the strong ion gap will be 0. What about the anion gap? We said that there is loss of chloride with gain of bicarbonate with the same value, so there is no change in this in the sum of chloride and bicarbonate, so the anion gap will be normal anion gap. So in cases of vomiting, there is a hypochloremic metabolic alkalosis with normal anion gap and base excess. COPD, this is chronic retention of carbon dioxide with activation of carbonic anhydrase to increase the bicarbonate. But increase in the carbonate or retention of bicarbonate is associated with loss of chloride. So this is, in this case, there is loss of chloride. So the difference, this is strong ion difference, sodium minus chloride, will be more than 40. This is hypochloremic metabolic alkalosis. Increase in the bicarbonate, this increase in the buffer base, more than 40. No fixed acid has been added, so the strong ion gap is 0, which is the difference between strong ion difference and the buffer base. And at the same time, we have mentioned that this retention of bicarbonate with loss of chloride with the same mole equivalent, so the anion gap will be normal anion gap. There is increase in the bicarbonate in this case, as simply there is a base excess. So in COPD patient, stable state of COPD, the patient will have hypochloremic metabolic alkalosis, normal anion gap with base excess. Lastly, this is the DKA. DKA is an addition of fixed acid, which is the keto acid. This neutralizes part of the bicarbonate, so there is loss of bicarbonate. When you come to the DKA, no change in sodium, no change in chloride, so the strong ion difference is normal. But what about the state? Strong ion difference is normal. But when you look at the buffer base is loss of bicarbonate is less than 40. It is a metabolic acidosis. Strong ion difference, a strong ion gap, when you look at it, difference between strong ion difference and the buffer base is large. There is a retention of keto acids, which neutralizes part of the bicarbonate. So the strong ion gap is large. Here, this is a very important point. When you come to the anion gap, there is loss of bicarbonate, loss of normal chloride, loss of bicarbonate. This gives a high anion gap. But about the buffer, the base excess of the base deficit, this is base deficit, there is loss of bicarbonate. So the DKA will be characterized by normal strong ion difference, but high anion gap metabolic acidosis with the presence of added keto acids and is base deficit. Thank you.